is everybody today? All righty. So let's go ahead and take a look back. Oh, we get my screen shared. We'll take a look at where we left off. I hope that if you, I guess, any of y'all have classes that you got to miss yesterday because of Veterans Day. All righty. Righty. So on Monday, we started talking about percents. And we talked about how a percent is a number that we use to look at per 100. It's a number that is less than 1. And we can use it to look at per 100 or per 100th, okay? And we've talked about how we can convert a percent to a decimal and a decimal to a percent. So what we'll start out with is we will go ahead and take a look at our homework answers and get that checked first. And if you have any questions, let me know. So let's see, this is lesson 47. All right. Let me find my little pen. There it is. All righty, so going down our homework, we had to change from percents to decimals. So remember that when I'm changing from a percent to a decimal, I drop my percent sign and I move 2 places to the left. So this would be 0.927. And we said that you can either have the 0 in front of the decimal or just a decimal. It's up to you. So I drop it, move 2. So 0.028. Drop it, move 2. 1.33. Drop it, move 2. 4.981. Drop it, 1, 2. 0.057. Drop it, move 2. So I have to fill in. So 0.0067. Drop it, move 2. 0.01. Drop it, move 2. 0.07. Drop it, move 2. So 0.999. Any questions on that first section? Changing from a percent to a decimal, we drop our percent sign and move our decimal 2 places to the left because we are dividing by 100, okay? Now to change from a decimal to a percent, we move our decimal place 2 places to the right because we're multiplying by 100 and we add the percent sign. So here I would bump 2 places to the left and have 58.3%. 2 places to the right, 1.9%. 4, my decimal's here, so it goes 2 places to the right, so that would be 400%. 2 places, 752.3%. 1, 2, 9%. 1, 2, 0.5%. We had already done that one. 2 places, 819%. 2 places, 408%. Any questions on changing decimals to percents? Everybody good? All righty. So then we looked over and we were working with our fractions to decimals and decimals to fractions. So over here, if we had the repeating 0.3 repeating as my decimal, we know that that is a fraction equal to 1/3. 0.25 is 1/4. 0.83 repeating is going to be 5/6. 0.125 will be 1/8. And 0.9 is 9/10. Any questions on those? All righty. Activity 6, we had our proportions. And so we talked about how we know with a proportion, those are 2 equivalent fractions. And I can solve for my unknown by cross multiplying. So here I would have 25x equals 12 times 175. So 25x is equal to 2,100. Divide by 25, divide by 25, and x is equal to 84. The next one, 11x is equal to 49. Divide by 11, divide by 11, and x is equal to 49 over 11. It told us that we could just leave it as an improper fraction if we need. We could just leave it as an improper fraction if it wasn't a whole number. So then I have 8x is equal to 17. Divide by 8, divide by 8. So x is equal to 17 over 8. Any questions on those? Awesome. All righty, then moving right along in lesson 48, we were dealing with finding the percent of a number. And we learned the equation that percent times whole equals part. And so we looked at what I can plug in of the two pieces of the, I need three, let me say this. There are three things that I am able to find. If I have two of the other pieces, I can find the third. So we had to plug in what we knew and solve for what we didn't know. So here, what is 25% of 92? So 25% of 92 equals x. So we'd have to change that to 0.25 times 92 equals x. And when I multiply, excuse me, we find that x is equal to 23. Number 3, what is 18% of 40? So 18% of 40 is 18% times 40 equals x. I have to convert 18% to a decimal, so I have 0.18 times 40 equals x. So x ends up equaling 7.2. Number 4, what is 7% of 50? So again, 7% times 50 equals x. So 0.07 times 50 equals x, and x is equal to 3.5. On that 7%, be careful because you end up with a decimal 07 because you have to move your decimal 2 places to the left. What is 1.5% of 60? 1.5% times 60 equals x. So 0.015 times 60 equals x. And we find that x is equal to 0.9. Okay. Let's see.
Wait. 1.5% should be big, like 1.5% of 60 should be bigger than 60, right?
No, it's 1.5%. So remember, as a decimal, 1.5, I would move my decimal 2 places to the left, so I'm doing 0.015. So when I have 60 times 0.015, 5 times 0 is 0, and then so that's my placeholder 0. So 5 times 6 is 30, carry my 3. 6 times 1 is 6, plus 3 is 9, and then that's a 0. And I have 3 decimal places, so my decimal goes before my 9, so it's 0.9. Because 1.5% is 0.015 as a decimal. Are you good? Okay. So 0.9. All right, then we had number 8, and we have 66 is 55% of what number? So 55% times what equals 66? So that would be 0.55W equals 66. Divide by 0.55, divide by 0.55. So the number that we are looking for is going to be 120. And then Number 11. 75 is what percent of 30? So what percent of 30 equals 75? Divide by 30, divide by 30. So my percent is going to be equal to 2.5, but then I have to change it and move my decimal to the right two places. So that would be 250%. Okay, so I solve for a decimal, but then I have to convert my decimal to a percent. So any questions on 3, 4, 5, 8, or 11? All righty. Oh, 2, 3, 4, 5. All right. Keep on moving. Okay, so we are going to start with lesson 49. We are dealing with fraction percent conversions. So lesson 49 says to change a percent first, to change a fraction to a percent, first change the fraction to a decimal. So that's going to be the first thing that you need to do. Well, okay, then change the decimal to a percent by multiplying by 100 and placing the percent sign after the number. So that's the second thing you do. Okay, so first change your fraction to a percent. First change your fraction to a decimal, then, and actually, let me move that one. First, change your fraction to a decimal, then change the decimal to a percent. Okay, so the example they gave us is 1/8. So first, you would divide 1 by 8, and that is 0.125. Then you multiply that by 100, which is just the same as moving your decimal 2 places to the right. So you get 1.25, and then add your percent symbol. Okay. So to change a percent to a fraction, you're going to reverse the process. Okay, so to go from percent to fraction, then you are going to first remove the percent symbol and then divide by 100 and then convert to a fraction. So first, remove the percent symbol and divide by 100, then convert from decimal to fraction. Okay. So let's take a look at this. It says express 75% as a fraction. So the first thing they said is to drop our percent sign and divide by 100. Dividing by 100 is the same as moving your decimal 2 places to the left. So 75% becomes 0.75. And then to convert 0.75 to a fraction, remember that if you know your percents to fractions, that's great. You won't have as much work to do, but you could always just put 0.75. That means you're going to have 75 hundredths, okay? Remember, I can just put that over 100. Then I can just simplify. So divide by 25, divide by 25, that gives me 3/4. So if you do not know your decimal to fraction conversions by, if you haven't memorized some of them or all of them, you can always just put whatever your fraction or whatever your decimal is over whatever number is the largest or is the furthest place value from the decimal. So in this one, this is my tenths, this is my hundredths, so I have to put 75 over 100. Okay, if it was 0.8, that means I would just do 8 over 10 because it's only one decimal place after, or one place after the decimal point, so I would put it over 10. If it's 2 places after the decimal, it goes over 100. If it's 3 places after the decimal, it would go over 1,000, and then you're just going to simplify. Okay. All right, so let's look at our classwork over here. So think about a fraction. Hopefully this is one that you know a fraction of 1/2 is equal to, if I was going from fraction to decimal, that would be 0.5. And so as a percent, it would be 50. Okay, hopefully that's one that you just memorize. Now, in this next one, if you haven't memorized that 1/6 is going to be 16, or it's going to be 0.16 repeating, then what I've got to do is I've got to say 6 into 1. It won't go, so I've got to have my decimal. 6 will go into 10 one time. 1 times 6 is 6, and I subtract. 10 minus 6 is 4. Add a 0 and bring it down, so now I have 40. 6 will go into 40 6 times. 6 times 6 is 36, and I subtract, and I've got a 4, and I can see I've got this pattern here. Now, what I've got to do here, when I have a repeating digit, okay, and I've got to change it from a decimal to a percent, what I want to do is I want to go ahead and take this out, because remember, I'm going to have to move my decimal 2 places to the right. I've got a repeating digit here. So that means that would be the same as 0.1666, and I could repeat that way. So then that way, when I move my decimal 2 places right there, then I've got 16.6, and I can have my repeating digit after the decimal, okay? I can't put a repeating digit after my whole number, 6, because that would mean, and when I have a whole number like that, that changes my value tremendously, okay? This is still a whole number of 16 with just that 0.6 repeating. Number 6 is 166 to 1,666 to 16,666. So my value changes dramatically if I have a repeating whole number. So I have to be super careful that when I have a repeating decimal and I'm changing a repeating repeating fraction, when I have a repeating decimal that I'm changing to a percent, I want to make sure that I have that repeating digit after my whole number. Okay, so I have to have that repeating digit after the decimal. 3/8. Again, if you don't know, you're going to do 8 into 3. 8 won't go into 3, so I have to do it into 30. I put my decimal after 3 and add a 0. So 8 will go into 30 3 times. 8 times 3 is 24. Subtract. That's going to give me 6. Put a 0. Bring down my 0. 8 will go into 60 7 times. 7 times 8 is 56. Subtract. 60 minus 56 is 4. Add a 0. Bring it down. 8 will go into 40 5 times. 8 times 5 is 40. So I see that this is 0.375 as a decimal. 2 places to the right, so I have 37.5%. Any questions on how we did those? First, change to a decimal, then change your decimal to a percent. The way you change a fraction to a decimal is to divide the numerator by the denominator. Now, going from a percent to a decimal. So remember, with this one, I do have this repeating decimal, but I'm going to drop my percent sign. I'm moving 2 places to the left, so that means that my decimal is 0.3 repeating. And hopefully you've memorized that 0.3 repeating is just 1/3. Okay, that's one of those that's good just to memorize. Same thing here. I drop my decimal, I drop my percent, move my decimal 2 places, so I've got 0.6. which is the same as 6 over 10. But what I want to make sure that I do is I go ahead and reduce that fraction. They are both even numbers, so I divide by 2, and I've got 3/5. So I always want to make sure my fraction is in simplest form. Hopefully you know that 25% is equal to 1/4, but if you don't, drop your percent, decimal 2 places to the right, so you have 0.25. To express that as a fraction, it would be 25 over 100. 2 places are after the decimal, so that's why I put it over 100. I reduce, divide by 25, and that is 1/4. So any questions about those? Alrighty, let's go ahead and take a look at what we'll do is let's do the top 4 together, and then I'm going to have you do the next 3 on your own in class. So this will be together, this will be in class, and this will be homework. Okay. So 1/4, 4 into 10. We'll go 2 times. 2 times 4 is 8. Subtract, and that's 2, and the 0, and bring it down. That'll go 5. So then you have 0.25 as your decimal, which equals, move your decimal 2 places to the right, and add your percent sign. Okay, 1/3. We looked at that a minute ago. So when I've got 3 into 1, we know what's going to happen, but we're going to work it out mathematically anyway. So 3 will go into 1, 0 times, but 3 will go into 10 3 times. 3 times 3 is 9. Subtract, and I've got a 1. 0, bring it down. I'm going to keep on going. Okay, so I've got my 3, excuse me, my 0.3 repeating. But when I write it out as a percent, I need to make sure that I move my decimal 2 places to the right, but I want to make sure that my repeating digit is going to go after the decimal. So I'm going to have 33.3. My repeating digit goes after the decimal, and then I add my percent sign. Okay, so if it's a repeating decimal, take it 2 places, or move your decimal to 2 places, and then put your repeating digit after the decimal. All right, 66.6 repeating. Now, let's see, in this situation, so one of the things they don't really tell us about the process for converting, and there's a whole confusing way that was in another book that I had one time. I'm trying to remember. And I don't even want to bother because I think it'll be too confusing to show y'all that. So for right now, the main thing to do with our most common repeating decimals is just to learn the fraction to percent conversions, just like 1/3 is 0.3 repeating. And so that way it ends up being 33 1/3%. And that 66.6 repeating is my 0.6 repeating, I know, is a fraction of 1/6. Later on in higher math, it'll go through the whole thing. You have to let one value equal X and then subtract it. And so we just won't even bother with that right now. Just memorize your repeating decimal to fraction conversions. All right, and then finally, but this one was because we dropped our percent sign, move it 2 places to the left, so that's 0.6 repeating, and we know that 0.6 repeating is going to be 1/6. 40%, drop your percent 2 places to the left, that's going to be 0.4. 0.4 is equal to 4 over 10. So there we divide by 2, and we have 2 over 5 as our reduced fraction. Okay, so I want you guys to go ahead and work those middle 6. You've got 3 fractions to percent conversions and 3% to fraction conversions. Oh, and I totally wrote the wrong thing. that was 2/3. Not the 1/6. I was looking at the 16.6 repeating and did the 1/6. So work on those middle 6 right now. Mm-hmm. Okay, so as you finish up, you can look up and check yours. If you have any questions, let me know and we'll work through them. All right, so then those last few will be homework. Okay, let's move on to activities 3. We're going to do a couple of things to review right here. It says find the least common multiple of each set of numbers. Remember we talked about how multiples mean, like with 9 and 12, 9 times 1, 9 times 2, 9 times 3, 9 times 4. So instead of having to list out a whole bunch of multiples, we can use our prime factorization to determine what the least common multiple is. The first step is to list out our prime factors. So 9 would be 3 times 3, so we could write that as 3 squared. 12 is going to be 2 times 2 times 3, so I can write that as 2 squared times 3. Remember, with least common multiple, I need to make sure to multiply each factor that is represented in the prime factorization of every number, but I only list it once and I use the highest exponent. So when I'm listing out my number 2, I'm going to use 2 squared. And then for 3, I use 3 squared. So I'm going to have 2 squared times 3 squared. 2 squared is 4. 3 squared is 9, and 4 times 9 is 36. So the least common multiple of 9 and 12 is 36. All right, 12 and 15. We've already said that 12 is going to be 2 times 2 times 3. 15, which is 2 squared times 3. 15 will be 3 times 5. So again, here I look at all my numbers. I have to represent 2, 3, and 5. I have to represent each prime factor to the highest exponential form. So 2 squared times 3 times 5. 2 squared is 4 times 3 times 5. 4 times 3 is 12. 12 times 5 is 60. So my least common multiple equals 60. Go ahead and do the last one, and then we'll check it. Go ahead and do the last one on your own. List the prime factors of 24, prime factors of 30. Remember, start with your smallest prime factor, which I always like to start with 2 if it's an even number. And then break down each number into prime factorization. Represent it as exponents if there's a repeating digit. Okay, so prime factorization of 24. 2 will go into 24 12 times, and I have to break down 12. 2 will go into 12 6 times. 2 will go into 6 3 times. So 2 times 2 times 2 times 3. I wrote that as 2 cubed times 3. 30 is divided by 2, and that gives you 15. And my prime factors of 15 are 3 and 5. So I have a 2, a 3, and a 5. I've got to list the highest exponential form of each. The only one that has an exponent is 2. So I have 2 cubed times 3 times 5. 2 cubed is 8. 2 times 2 times 2 is 8. 8 times 3 is 24. And 24 times 5 is 120. So my least common multiple is 120. Any questions about least common multiple? All right. Now, along the same line, dealing with our prime factorization dealing with radicals. Okay, so let's think about if I'm breaking down the square root of 240. My smallest prime factor, it's an even number, so that's going to be 2. And 240 divided by 2 is going to be 120. I can divide 120 by 2 also. Excuse me. And 120 divided by 2 is going to be what? 50? No, 60. Good grief. And then 60 divided by 2 is going to be 30. And 30 divided by 2 is going to be 15. And 15 divided by 3 is 5. So I have 2 times 2 times 2 times 2 times 3 times 5. Remember, my understood index is going to be a 2 there. So that 2 tells me how many buddies I have to have. So these guys buddy up and these guys buddy up. So that means they each are able to come out as a whole number. I multiply them together. And then under my radical, I still have a 3 and a 5. So 2 times 2 is 4. And then under my radical, 3 times 5 is 15. So my prime factorization will be 4 times the square root of 15. Okay, same thing with 108. Smallest prime factor is 2. So half of 108 is going to be 54. So half of 54 is 27. 27 is an odd number, so I know it's not divisible by 2, but I know it is divisible by 3. And it's 3 times 9, and 9 is 3 times 3. Again, my understood index is a 2. So I know that I'm looking for 2 buddies. So I have 2 2s and 2 3s that are able to come out. That 2 and that 3 are going to be the whole numbers. The 3 that would not buddy up or couldn't buddy up stays under the radical. So I have 6 times the square root of 3. Now, 3 times the square root of 45. I'll leave my whole number 3 alone. Underneath the radical, I'm going to start breaking it down into prime factors. It's not even, so I cannot divide by 2. I check to see if it's divisible by 3, and it is because 5 and 4 is 9. 9 is divisible by 3. And so 45 divided by 3 is going to give me 15. And then 15 is 3 times 5. Again, I already had my whole number 3 that has to move right over here. Then I have these 2 3s that can come out, and I'm going to have to multiply that by the original number 3 that I have. My 5 stays under the radical. 3 times 3 is 9, and I have 5 under the radical. Okay. The square root of 432, big number. So if I'm looking at 432 divided by 2, so I think about, excuse me, half of 400 is going to be 200. Half of 32 is 16. So half of 432 is 216. So then I think about half of 216. Well, half of 200 is going to be 100, and half of 16 is 8, so 108. And then half of 108 is going to be 54. We've already broken down 108, so now I'm down to 2 times 2 times 3 times 3 times 3. Now, when I've got this many digits, I want to check it and make sure that I have my right numbers. So I'm going to say 3 times 3 is 9. 9 times 3 is 27. 27 times 2 is going to give me 54. 54 times 2 is 108. 108 times 2 is 216. 216 times 2 is 432. So see, I have too many 2's in here, don't I? So I wrote an extra 2 down, so it's a good thing I checked it. So let's see. Yeah, so I should only have 4 2s, so I'm going to erase that one right there and make sure. Now I'll multiply it one more time to make sure. 3 times 3 is 9. 9 times 3 is 27. 27 times 2 is 54. 54 times 2 is 108. 108 times 2 is 216. And 216 times 2 is 432. All righty. So now I start buddying up. My understood index, remember, is a 2. So I've got these buddies and these buddies and these buddies. So I'm able to pull out a 2, and a 3 that I'm going to have to multiply all those together. I have a 3 that's left under the radical. So 2 times 2 is 4, and 4 times 3 is 12. And then I have my square root of 3 left under my radical. Okay. And the last one, 2 times the square root of 700. I leave my 2 there. Half of 700 is going to be 350. Half of 350 is going to be 175. I can't divide 175 by 2, but 175 divided by 3, 175 divided by 3 won't work either. So let's do 175 divided by 5, because remember, I'm only working with prime factors. So after 3 comes 5. 175 divided by 5 is 35. And then 35 is 5 times 7. Again, I can check it. 7 times 5 is 35. 35 times 5 is 175. 175 times 2 is 350. 350 times 2 is 700. So I am good now. Circle my buddies of 2s, my buddies of 5s. My 2 and my 5 can come out. I already had a 2. Now I've pulled out a 2, and I'm pulling out a 5. I have a 7 that stays under the radical. 2 times 2 is 4, and 4 times 5 is 20. And I still have a 7 under the radical. All righty. We are going to go ahead and have activities 5 as homework. What is 27% of 150? This is where you're going to use your percent. Well, I don't know why I keep doing that. Percent times whole equals part. So plug in what you know using that formula, and you can solve for the unknown. So that will be for your homework. Okay, so let's see, today is 11, 12, excuse me, and I don't know why I keep getting so yawny. Sorry for that. All right, so 11, 12, we'll do activities 5. Scientific notation real quick. Remember, if I have a positive exponent, my decimal moves to the right that many places. So 1, 2, 3, 4, 5, 6, 7. It would move there. I'd fill in with zeros. So I would have 5, 7, 1, 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. I go back and put my commas in. 4.892 times 10 to the 8th. Move my decimal 8 places to the right. 1, 2, 3, 4, 5, 6, 7, 8. Fill in with zeros. So I have 4, 8, 9, 2, and then 5 zeros. 1, 2, 3, 4, 5. Put in my commas. Negative exponents means I move my decimal to the left. So if I've started at 7.4, I'm going to have to go backwards. 1, 2, 3, 4, 5, 6, 7. So my decimal goes there. Fill in with all my zeros. So I have decimal 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6, and then 7, 4. The number 6 times 10 to the negative 8. I need to move to the left 8 places. Remember, my decimal starts after my 6. So 1, 2, 3, 4, 5, 6, 7, 8. My decimal now is there. Backfill with zeros. So I have 1, 2, 3, 4, 5, 6, 7 zeros. So 1, 2, 3, 4, 5, 6, 7, and then the number 6. Okay. positive exponent, my decimal moves to the right, negative exponent, decimal moves to the left. Positive exponent, I know that I'm going to have a big number in standard form. Negative exponent, I know I'm going to have a little number in standard form, meaning a decimal with a bunch of zeros. All right, so here, remember to go from standard form to scientific notation. I look at my number. I start with my first non-zero number and go to my last, and I look to see where I'm going to put my decimal to make this a number that is greater than or equal to 1, but less than 10. So I know I could put my decimal between the 9 and the 7, and that makes it a number of 9.723. So there's my mantissa. So now if my original decimal in standard form is right here, and I'm having to move it to here, I'm having to move 1, 2, 3, 4, 5, 6, 7, 8, 9 places to get it there. So then it would be times 10 to the 9th, because to get it back to standard form, I'd have to move my decimal 9 places to the right. All right, my next one, my first non-zero number is 2. My last non-zero number is 6. So I know I'm going to use this as my mantissa. My decimal will go between 2 numbers to make my number between 1 and 10. So my decimal will be right there. Right now it is at the end, and I've got to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places. So my mantissa is 2.516 times 10 to the 11th. Now remember, when I'm dealing with decimals with bunches of zeros, I'm going to have a negative exponent. Again, I'm going to look at this number right here. My first non-zero number is 1. My last is a 2. Remember, my number has to be greater than or equal to 1, but less than 10. So I couldn't put my decimal between 0 and 2 because that would be greater than 10. So my decimal is going to have to go between the 1 and the 0. Okay. In my original problem, my decimal starts right here, and I have to move it 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So my mantissa is 1.02 times 10 to the negative 9th place. Then on my last one, first and last non-zero digit, put a decimal between the 5 and the 4. To get it from its original place and move it to between the 5 and the 4, I have to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. So I have 5.4 times 10 to the negative 10th power. Any questions on scientific notation? All righty. Well, we're a few minutes over on our break, so let's go ahead and take a 5-minute break, and then we'll come back and start talking about percent decrease. All right, so take a break. All righty, let's get ready to start back dealing with percent decrease. This is lesson 50 on page 109. All right, so when we talk about a percent decrease, so think about if you have ever been saving your money for something and maybe it's on sale and maybe there's a percent decrease. Or maybe you have been reading and you have to read so many pages and you're trying to figure out the decrease, or maybe you have something, the example they're going to give us in a minute is like somebody driving laps and they, about the decrease in the number of laps that are left remaining. But whenever we're talking about a percent decrease, we have to consider what our original amount is and what our new amount is. And when I use those two pieces of information, I have a formula that I can use here to find what the percent decrease is. So it says to find the percent decrease, start by finding the difference between the original amount and the new amount. Okay, so this is finding percent decrease. The first thing I've got to do is find the difference. Remember, the word difference indicates that I'm going to subtract. And I'm going to subtract the original amount and the new amount. So original minus new. Then it says I want to divide the difference by the original amount. And so this is the formula that we see right here. Okay, this right here sets us up to where we have the original number minus the new number divided by the original number. Okay, so that's my formula. Percent decrease equals the original number minus the new number divided by the original number. So the example they give us is Steve has 60 of the 75 laps remaining in the race. What percent of the laps has Steve completed? So remember, my original amount is what's going right here. My new amount is right here, and I have to divide by my original amount. So I have 75 minus 60 is 15, and I'm dividing by 15. So dividing by 75. So 15 divided by 75, I can write that as a reduced fraction. 15 over 75 reduces to 1/5. Well, if I know what my equivalent fractions are, fractions, decimals, percents, then I go ahead and I know that 1/5 is equal to 20%, or it's equal to 0.2. If I don't, then I divide my 5 into 1, which I put my decimal. Now it's 5 into 10, so now it's 0.2. And 0.2, I know I moved my decimal 2 places to the right to make 20%. Okay, so now we're using this formula. We'll solve it possibly for a fraction. We've got to convert our fraction to a decimal and the decimal to a percent. Okay, so we're kind of doing all of it here together. So let's look at classwork 1. It says to find the percent decrease. The first thing I want you to do is go ahead and write the formula. Percent decrease equals, I'm going to use ORIG minus new over original. So that way I can just look up at my formula. So for the first one, percent decrease equals, my original amount is 50. So I know I have 50 minus my new amount is 35. So I have 50 minus 35 over 50. I put my original amount in the denominator. So 50 minus 35 is 15 over 50. That will reduce, and I can have, they're both divisible by 5, and that gives me 3 over 10. Okay, I know that 3 over 10 as a decimal would be 0.3. And 0.3 as a decimal is equal to 30%. So the first thing I did was so my percent decrease equals 30%. I start with my original formula, put in my original amount minus my new amount over my original amount. 50 minus 35 is 15. 50 is my original amount, so 15 over 50. I reduce my fraction to simplest form, and that ends up being 3 over 10. Then I know that 3 over 10 is equal to 0.3 as a decimal, and 0.3 converts to 30% as a percent. Okay, let's look at the next one. All right, so my original amount, so I'm doing percent decrease is equal to, my original amount is 144 minus my new amount of 96 over 144. So 144 minus 36 is going to be 48, no. Yeah, 48 over 144. I'm going to reduce it. Since I don't know right off, I'm just going to go ahead and start by twos. That'll at least cut them in half. 48 divided by 2 is 24. 144 divided by 2 would be 72. I see that these are divisible by 2 as well. 24 divided by 2 is going to give me 12. 72 divided by 2 is 36. I'm starting to see light at the end of the tunnel. I've got 12 over 36. 12 divided by 12 is 1. 36 divided by 12 is 3. So I'm at 1/3. This is where I know that 1/3 is equal to 0.3 repeating. And I know that when I convert 0.3 repeating, that I want to have that repeating digit after my decimal. So I've got to move it 2 places to the right, have my repeating digit after the decimal. So 33.3% or 33.3 repeating percent. So when I have a formula like this, I just plug in the information that the problem gives me and solve for what I don't know. Okay. Let's go ahead and look at the next one. New tires have an average tread depth of 11 over 32 of an inch, or 11/32 of an inch. Okay. Most states have laws allowing cars to legally run with tires having at least 1/16 of an inch of tread. What percent decrease in tread depth is the maximum allowed by most state laws? Okay, so I've got to think about this. I'm dealing with fractions. Fractions can make me feel very uncomfortable, but we know how to work with fractions. We know that if I'm subtracting fractions, I'm just going to have common denominators. I also know that when a fraction is the same as a division problem. So we're just going to work through it. My formula is percent decrease equals original minus new over original. So my original number was 11 over 32. My new number is 1 over 16. So I have 11 over 32 minus 1 over 16 over 11 over 32. This looks very unusual. It makes me feel very uncomfortable, but I'm going to think about the things that I know how to do. The first thing I'm going to start with is 11 over 32 minus 1 over 16. Remember that if I'm subtracting fractions, what I'm going to do is I'm going to come down here at the bottom and give myself some space. So basically I have 11 over 32 minus 1 over 16. The first thing I've got to do is have common denominators. Whenever I'm using common denominators, I want to look and see if one of my numbers that I already have would work. And it would. I know that 16 is half of 32. So I'm going to keep 11 over 32 minus. Now I've got to change my denominator of 16 to 32. 16 times 2 is 32. So if I multiply my denominator by 2, I have to multiply my numerator by 2. And 1 times 2 is 2. So now I have 11 over 32 minus 2 over 32. 11 minus 2 is 9 over 32. Okay. So now I've got 9 over 32 over 11 over 32. Again, I'm kind of uncomfortable. I've got a fraction divided by a fraction. So I'm going to change that to where it makes me feel a little more comfortable, where I have 9 over 32 divided by 11 over 32. Now think about dividing fractions. We just recently worked on this. Remember, we have keep, change, flip. So notice when I'm in this situation, it looks very different, but it's the same as just having 9 over 32 divided by 11 over 32. So I'm going to keep my first fraction, change from division to multiplication, and flip my second fraction. Okay. Now remember, when I'm multiplying fractions, I look to see, is there anything that I can reduce? Do I have anything in the numerator that can reduce with anything in the denominator? And I do. I can cross out those 32s. So I don't even have big numbers to multiply anymore, and those each became 1. So 1 times 9 is 9, and 11 times 1 is 11. So my percent decrease, I'm dealing with 9 over 11. So 9 over 11 has to be changed to a percent. First, I've got to change it to a decimal. So 11 into 9. 11 won't go into 9, so I've got to put my decimal in a 0. 11 will go into 90 8 times. That would be 88. And 90 minus 88 is 2. Add another 0 and bring it down. 11 will go into 20 one time. 1 times 11 is 11. I'm going to subtract. 20 minus 11 is 9. Add a 0, bring it down. 11 will go into 9 8 times. I'm starting to see a pattern here. 8 times 11 is 88. That's 2. Add my 0. So we can see here I've got 0.81 repeating. Okay? So I'm going to bring this over here. Remember, I said whatever my repeating part needs to go after my decimal. So right now I've got 0.81 repeating. So that means I would have 81.81. I'd put my repeating sign over the 81 after the decimal and add my percent. So 81.81 repeating percent. The main thing that I want you to get from this is when I have a repeating digit or digits, whenever you're converting from a decimal to a percent, make sure that you put the repeating information after the decimal. So if it's only 1 digit after, then you would have the numbers before the decimal, 1 digit repeating after the decimal. If it's 2 repeating digits, both of them have to be after the decimal repeating. Okay? Any questions about that? All right, let's look at the next one. It says tires are considered safe to use in rainy condition if they have at least 1/8 of an inch of tread. What is the maximum percent decrease in tread depth that is still safe for any rainy conditions? Excuse me. So we're having to refer back to our original problem we just looked at, where new tires have the tread of 11/32 of an inch. Okay, so I know that in this, my percent decrease equals original minus new over original. My original was 11 over 32. My new is now 1/8. All over 11 over 32. So again, just like we did earlier, my first step is I've got to do common denominators. So 11 over 32, common denominator again is going to be 32 because 8 times 4 is 32. So I can make that a 32. I multiplied 8 by 4 to get to 32, 1 times 4. So I have 4 over 32 over 11 over 32. 11 over 32 minus 4 over 32. 11 minus 4 is 7. So I have 7 over 32 divided by 11 over 32. Now I'm going to do exactly the same thing. I'm going to write it as a division problem. 7 over 32 divided by 11 over 32. Keep, change, flip. My 32's cancel. So I have 7 over 11. Now I've got to convert that to a decimal, then a percent. I'm going to come over here. So I've got 7 over 11. I'm going to have 11 into 7. It will not go, so I add a decimal and a 0. 11 will go into 76 times. 6 times 11 is 66. Subtract, and I've got a 4. Add my 0, bring it down. 11 will go into 40 3 times. 3 times 11 is 33. I'm going to subtract, and 40 minus 33 is 7. I'm seeing a pattern here, so we can see that I'm going to have 0.63. My 63 is my repeating part. So to write that as a decimal, 0.6363 dot, dot, dot. So that means to write it as a percent, I move my decimal 2 places to the right. I have my repeating after my decimal, add my percent. So 63.63 repeating percent. And then the last one. Tires are considered safe to use in snowy conditions if they have at least 3/16 of an inch of tread. What is the maximum percent decrease of tread depth that can still be safe in these conditions? So I'm going to erase this at the bottom so I've got some room to work. Okay. Again, I'm using my original amount from my first equation. I've got percent decrease equals original minus new over original. Notice that I'm rewriting the formula each time I'm working the problem. The reason I do that is because then I've got the problem right in front of me. So when I start plugging in the numbers that correspond with each thing, I make sure to put them in the right place. It just helps me to keep from making a mistake. So original minus new over original. My original amount was 11 over 32. My new amount was 3 over 16. My original in my denominator is 11 over 32. We've already looked at this and we have seen that we can use a common denominator of 32. Common denominator of 32, 16 times 2 is 32, so 3 times 2 is 6 over 11 over 32. Now I'm going to subtract 11 over 32 minus 6 over 32, and 11 minus 6 is 5 over 32 divided by 11 over 32. Write it as a division problem. 5 over 32 divided by 11 over 32. Remember, now I'm going to do keep, change, flip. 5 over 32 times 32 over 11. My 32's cancel, and I have 5 over 11. So now I've got to convert 5/11ths to a decimal and then to a percent. 11 into 5, it will not go, so I add my decimal and a 0. 11 will go into 50 4 times. 11 times 4 is 44. Subtract. 50 minus 44 is 6. Add another 0 and bring it down. 11 will go into 60 5 times. 5 times 11 is 55. 60 minus 55 is 5. I can see my repeating pattern starting again. So I know I'm going to have 0.45 repeating. 0.45 repeating will be 45.45 repeating percent. Now, the things I want us to kind of look through with these, I know That was a lot to kind of look at. Number one is the formula. It's pretty self-explanatory that when you've got the formula, you just plug in your original and new information divided by the original. Now, lucky for us, they gave us some challenging numbers and they decided to throw some fractions in there. So we had to use our fraction skills that we've previously worked on. We had to look at subtracting fractions. We had to find a common denominator and be able to subtract. And then we had to use dividing fractions. And we had to think about how we do keep, change, flip to divide our fractions. Then after that, we had to change fractions to decimals, and then decimals to percents. But not only was it just was it just easy percents to convert to, they used repeating decimals. So we also learned that extra skill of being able to learn how to convert a repeating decimal to a percent. The way we do that is we look at the repeating portion, make sure that goes after the decimal, and add your percent sign. Any questions about any of that? I know it hasn't exactly been the most fun, exciting, entertaining lesson. It's been kind of boring, I'm sure. But any questions about what we did? All righty. Let's look at activities 3, greatest common factor. A little bit ago, we did least common multiple. Greatest common factor and least common multiple are going to be a little bit alike in that we start out by finding prime factors. But that's all that's going to be in common. That's the only thing. So we're going to start with 36 and do prime factors. My smallest prime factor of 36 is 2, and that's 2 times 18. My smallest prime factor of 18 is 2, and that's 2 times 9. My smallest prime factor of 9 is 3, and that's 3 times 3. So I have prime factors of 2 times 2 times 3 times 3. Now this time I leave them all listed out separately. I do not combine them with exponents right now. 54 is even, so the smallest prime factor of 54 will be 2. Half of 54 is 27. 27 is not even, so I know it does not have a prime factor of 2, but it does of 3. And 3 times 9 is 27. And 9 will be 3 times 3. Again, I'm not going to list them with exponents. I will in my answer, but not right now. This is the point where I look to see what they have in common, okay? So this is where I look and I say, hey, I've got a 2 in common, and I've got a 3 in common, and I've got another 3 in common. Okay, so if I'm finding the greatest common factor, I have a 2 and a 3 and a 3, and I multiply those together. 2 times 3 is 6, and 6 times 3 is 18. Okay, so the greatest common factor is 18. The main difference between greatest common factor and least common multiple, I do list out my prime factors, but I'm not going to list these as exponents this time, and I circle what I have in common between both of them. In least common multiple, I have to represent every single factor that's listed for all of the numbers, and these I have to have them paired up. Okay, so let's look at 42 and 70. All right, smallest prime factor of 42 will be 2, and half of 42 is 21. 21 is an odd number, so it's not divisible by 2, but it is divisible by 3, and it's 3 times 7. 70, my smallest prime factor will be 2, and that's going to be 2 times 35. 35 is not even, but it's divisible by, let's see, not divisible by 3, and so we have 5 and 7. Okay, so again, I'm looking to see what they have in common. I've got 2s and 7s. So 2 times 7 equals 14. And then my last one, 48 and 92. 48 will be 2 times 24. 24 is 2 times 12. 12 is 2 times 6. And 6 is 2 times 3. 92. Half of 92 will be 46. half of 46 is going to be 23. And that's a prime factor. So I've got a 2 in common and a 2 in common and another 2 in common. So 2 times 2 times 2 is 8. So the greatest common factor is, what did I mess up on that? Oh, I circled the 2 of my 23. That was not a 2. I was going, I've messed up something there. Let's see. Don't need to erase those. Let me fix that real quick. 2 times 2 times 2 times 3. No, I missed something. Hang on. Let me fix that. Half of 48 is 24. Half of 24 is 12. Half of 12 is 6, and then 2 and 3. There we go. And then 2 times 2 times 23. There we go. So we have 2 times 2, which equals 4. And that is it. All righty, let's go ahead and have activities 4 as homework, fraction to decimal to percent. So this is page 110, activities 4, and I'm making a list. We'll go over the list of what all we've got for homework. Now, I wanted to go ahead and work on activities 5 and 6 together. We are converting from English to metric conversions, okay, from lesson 40. Let's back up to lesson 40. I know we did one of our conversion units, or one of our conversion chapters, but I want to say that we skipped over 40. Basically, if you turn back to lesson 40 and hold your page, you can see where we have our English to metric conversions, okay? So what I'm going to do, I think, I'll just kind of write it up here. So 1 mile equals 5,280 feet, which equals 1,760 yards. 1 yard is equal to 3 feet, which equals to 36 inches. 1 inch is equal to 2.54 centimeters, which is equal to 25.4 millimeters. 1 yard is equal to 0.91 meters. 1 mile is equal to 1.61 kilometers. And then 1 centimeter is equal to 0.39 inches. 1 meter is equal to 1.09 yards. And 1 kilometer is equal to 0.62 miles. All righty. So there are times where we have to convert from one unit of measurement to another. Okay, and so we set up kind of like we were doing a little earlier, where we have our fractions set up, where we set up equivalent fractions, kind of like we did with ratios and proportions. Is we have to set up our proportions to be able to convert our units. Okay, so if we look at their different measurements, and I need to go from inches to centimeters, what I want to do is I want to look at my different conversions that I've got, and I want to use, let's see what I do. Let me flip back real quick. Okay, so I want to look at the conversion that I have to go inches to centimeters. So what I'm going to do is I know that I've got 7 inches first. And when I have 7 inches, I know that if I were to set up a fraction or set up a proportion, remember this would be like 7/1 is equal to 2.54 centimeters, because remember my goal is to convert to centimeters, okay? So if I have inches in a numerator and inches in my denominator, those are going to, I need to multiply because I'm converting. My inches are going to cancel. So I'm able to multiply 7 times 2.54. And you know what? What I may do is hold off. Let's hold off on this activities 5 and 6. And we're actually going to go through, I've got lesson 40 to go back to later. Let's do that later instead of trying to just jump to it right now. So let's hold off on this for a second. I'm going to do this at the end of our percent unit. And I think what I may do is, since I'm going to make a note here that we're going to hold. Okay, so let's back up for just a minute. Let's look and see what our homework's going to be, because I don't want to put another, we've already done 2 sections and I don't want to do 3 sections today. That's just too much. So look back at lesson 49, page 107. Our homework will be those last 4 in each column on page 107. Page 108. We're going to have activities 5, where we use percent times whole equals part. Percent times whole equals part. So that's activities 5, page 108. And then the last little bit of homework will be activities 4 on page 110 from lesson 50, dealing with fractions, decimals, and percents. Okay, so that will be homework. So just those 3 sections. Okay, so what we'll do is it's 2:11. We're done a little early. If you want to go ahead and log off and be done, you're welcome to. If you would like to stay logged in and work on your homework, you're welcome to as well. So whatever you prefer is just fine with me. Okay, you can either go ahead and get started on your homework, or you can go ahead and log off a little bit early.
Thank you.
You're welcome.
Bye.
All right, bye-bye. See you guys on Monday.